Good morning. So we're going to work on the no solution case here. It says show that there is no triangle for which A equals 15, B equals 25, and angle A equals 85 degrees. So here we know that A is less than B. Now, the no solution case, if you scroll up, it'll be this one where A is less than H, or this one where A is less than or equal to B. But since we know that A is 85 degrees, that's going to be an acute angle. So it's got to be this case right here. But let's go ahead and find H, okay? Now remember, H was equal to B sine of A, and B was equal to 25, so we have 25 sine. Angle A was 85 degrees. Make sure your calculator is in degree mode. And you guys should get about 24.90. So here we know that A is indeed less than H, because A is 15 and H is 24.90. Now let's do another way that we can figure out that this is a no solution case. Now they gave us side A and they gave us angle A. They gave us side B. Let's see if we can try to find angle B and see if that makes any sense. Okay. So over here, we're going to use the law of sines because this is not a right triangle. It's pretty close to it. And we're going to try to find angle B. Now, I encourage you to pause this video and try to find it yourself. So, angle B, I'm going to go ahead and use these two because they gave us angle A and angle B. I'm going to switch it up so that angle B is on the left side. So I'm going to write sine B over little b is equal to sine A over little a. And I'm going to multiply both sides by side B. So now that cancels out. You're going to get sine of B is equal to side B, which is 25, and then sine of angle A, which is 85 degrees, divided by little a, which is 15. So now you're going to get sine of B is about 1.66. Now remember the amplitude of sine, it goes like this. What was the amplitude of sine? Well, it was bounded by -1 and 1. So think about it. Can you have sine of any angle that'll be greater than 1? No, you cannot. Or you can go ahead and plug it into your calculator. And if you want to find B, B is going to be the arc sine of 1.66, and it's going to be equal to, well, it's going to give you error. So therefore, this has no solution case. So let me just write this here. Remember that sine is bounded by positive and -1. And the amplitude of sine was 1. Okay, we're going to go into the two solution case here. They gave us, it says to find two triangles for which A is 12, B is 31, and angle A is 20.5. Let's go back up here. We know that A is less than B again, and this is a two solution case. So you either have this triangle right here, that's one possibly triangle, or you could have the big triangle, that one. So keep that in mind. Okay, we can find H. H is equal to B sine A. What is B? 31 sine of A, which is 20.5 degrees. Calculator should be in degree mode. This is going to give you 10.86. So let's verify. Do we have H less than A? less than B. H was 10.86, A was 12, and B was 31. So you should have two possible triangles, okay? So let's just try to find all the remaining missing sides and angle. I'm gonna find angle B first. So I'm gonna go sine of angle B over little b is equal to sine A over little a. Go ahead and multiply both sides by little b. So you should get sine of b is equal to 31 sine 20.5 degrees divided by 12, which is going to give you 0.9047. Now, how do you find the angle? You got to do arc sine of 0.9047, which is 64.78 degrees. Well, now that you have angle B, the easier one is to find angle C. Angle C, we know that in a triangle, they all add up to what? 180. So you can go ahead and do 180, subtract 20.5, subtract 64.78, and that should give you 94.72 degrees. What is left to find? You gotta find side C. So here I'm gonna do side C over sine of C. Whatever you want to find, you want that to be in your numerator. And you could use A over sine of A. And I'll leave you to verify this. It should be 34.15. What's our units? Meters. Okay, so which triangles do we really have? So keep in mind that B is 64.78. I'm going to scroll back up here for you. This is our case right here, okay? So you could have this triangle here. See how this is side B? So that means the angle opposite from it would be angle B, but that one was 64.78, but that angle right there looks obtuse, so it's not that triangle. It should be the other triangle, the bigger one, this one. So here's side B. The one opposite from it should be angle B. So we have this triangle here. I'm going to call it B1, okay? All right. Now, what's interesting about this is that this angle here is actually congruent to this angle right here. So if you want to find the other possibly angle B, I'm going to call this one B2 right here, which is this angle. How would we do it? Well, don't they form a linear pair? That means that you could find B2 by doing 180 minus whatever you get for B1. Okay, I'm going to scroll back down here. We're going to find the other possible triangle. So B2, like I mentioned, you go ahead and take 180 degrees and minus B1. And B1 is whatever you found on the left side right here, 64.78. So we're going to do 180 minus 64.78 degrees, which should give us 115.22. Okay, and then C is equal to 180 minus 20.5 and then minus 115.22. That should give you 44.28. Mm. Okay, now all you have to do is find side C. So side C, you're going to do C over sine of C is equal to A over sine of A. You can multiply both sides by sine C, sine of C. That cancels out. So then you should get C is equal to 12 sine 44.28 degrees divided by sine of 20.5, which is approximately 23.92. What's your units? Meters. And those are your two possible triangles.